there are a couple different forms to find the derivative. Okay, a couple different forms. In section 14.4, the one we're going to concentrate on, it's called, okay, it's the alternative form of the definition of derivative. We're going to get another definition of derivative later, and then we're going to have a bunch of rules in the next chapter. Okay, so for right now, we're just concentrating on this form. And actually, this is just a fancy way of asking to find the derivative, but you have already done it in this chapter. Okay, so here's our definition. It's the limit as x approaches some number. And then here, we did those average rate of change problems before spring break. That's all you did. You just didn't realize what you were actually finding. Okay, so I want the limit, but now I'm going to have f of x is a y value. When you plug a value into the function and get a number, that's a y value. So really, this is just y minus y over x minus x. This is just slope. So now we're going to take the limit of a slope function here, and that's going to be our derivative. Okay, so this answer, or not answer, this definition here is when you are trying to find the slope at a specific point. Okay, so that's key. When you are trying to find slope, and you have to be given a specific point. Okay, so we're going to look at 3 examples now, where we're going to ask you to find that derivative. All right, so example 1. Okay, find the derivative of f of x equals 2x squared minus 5x at 2. Okay, so this, another way of saying all of this would be to say, find the derivative of the function at 2, so f prime of 2. Okay, visually, what I'm looking for is if I look at 2x squared minus 5x, I know, let's see, I know that that is a parabola that goes through the origin. It also is going to be at the point 2, negative 2. So it looks, it's a very steep parabola here. But it looks like that. Okay, so I want to know what the derivative of is at this point. So really, if I drew in a tangent line, I'm looking for the slope of that tangent line at that exact moment, right there at that point. Okay, so we're going to use this formula to solve this question. Now, in your homework, you do not need to graph it. I just graphed it so you could see what we're looking for. Okay, but this is not necessary in terms of your work. Okay, but I'm looking for the point right here. So if I'm going to find the slope, I need 2 points to find the slope. Well, one of them is if I plug x into the function. The second point is where it's happening at, so at 2. So if I plug 2 into here, that gets me negative 2. Okay, so now I'm just taking the limit as x approaches 2. It's always going to be given to you in the problem. So wherever it's happening at, that value is going in here. Okay, now I'm going to take the slope of those 2 points. So y minus y, so that turns into a plus sign, all over x minus x. Okay, so I'm going to take the limit here. Now before spring break, and all this happened, remember we plugged in first. If I plug in 2 first, I get 0 down here. So that's bad. So now I got to play around with it for a little bit. So now that means I'm probably going to have to factor that. Now I get it's irritating, but you have to write this down every single time. That is a big deal in calculus. So I'm going to write that again. Limit as x approaches 2. This is factorable. gets me 2x minus 1. So that cancels. If I plug 2 now into here, now I can get an answer. So I get 4 minus 1. I get 3. Okay, so now you have to know what 3 is. 3 stands for the slope of the curve when x equals 2. So this is the slope right here. But that also doubles then as the slope of my tangent line. Okay, so we did the derivative, which you've done a bunch of times already with that average rate of change type problem. We found that number. That's the slope of the curve. That's also the slope of the tangent line. Okay, now it's going to take you another step. If you look at the second part of that question, let's find the equation of the tangent line. Well, if I'm going to write the equation of that tangent line, I need a slope. Well, I already got the slope. Oh, this is a mistake. That's 3. My slope is 3. I also need to know what that point is. Well, I got that point. That was that point that we found in the original problem. Well, if I have a slope and a point, we're going to write the equation of the line. Now in calculus, we always use point-slope form. So point-slope form, y minus y is equal to my slope and x minus x. Let's put our 3 in there. Do not change this to slope-intercept form. If you change it around and make a dumb mistake, we have to take points off. So leave it just like this. Now in your homework, I believe your book is going to change it to slope-intercept form. Don't worry about it. Mrs. Cook and I are both fine with you just writing it in point-slope form. So find the derivative of the function. That answer is 3. Find the equation of the tangent line. That answer is right here. All right, so let's look at another one and see if you got it. Let's look at example 2 here. Okay, so a two-parter. We're going to find the derivative first, and then we're going to find that equation of the line. Now again, just a visual. This is an upside-down parabola with a vertex at the origin. At x equals -2, I'm somewhere right here. So I want this. So before I even do the problem, look at this tangent line. The slope of this tangent line, is it going to be positive, negative, or 0? Well, I'm saying the slope of that line would be positive. So at least when I do the derivative, I should get a positive answer. Okay, so I know that I am taking the limit as x approaches -2. I also know I'm going to be finding the slope, so I need 2 points. So one point is -2. If I plug -2 in here, I get 4. 4 times -4, I get -16. And if I plug in x, I get that same function itself. All right, so let's go through now and do slope of that. So y minus y over x minus x. If I plug -2 in, I get 0. So I'm going to have to play around with that for a little bit. Always rewriting that limit statement. So I'm going to take out a -4. I'm going to factor that. So that cancels, which is good. If I plug -2 in here, -2 minus 2 is a -4. -4 times -4 is 16. 16, remember, is the slope of the curve when x equals -2. It is also the slope of that tangent line, which makes sense. It's a positive slope, It looks pretty steep, so it makes sense that that slope would be 16. Okay, so first part, derivative of this is 16. The second part, the equation of the tangent line. Well, I know my slope, that's already 16. I know my point is -2, -16. Let's just write that in point slope form. Okay, derivative, equation of the tangent line. All right, there's question 2. We're going to do one more to make sure you got it. If you think you're good to go, then we will see you tomorrow. If not, why don't you watch this third one and hopefully that'll help you out. All right, so same deal. We're going to find the equation of the tangent line and we're going to find the derivative. Okay, so derivative first. I know that it's the limit as x approaches 1. It always approaches the 1 of the x value of the coordinate. If I put 1 in here, I get 1/4. That's where the y came from. All right, so there's my point. My other point is x comma x squared over 4. All right, so y minus y minus x minus x. Well, this is really, the limit as x approaches 1 is really x squared minus 1 over 4 all over x minus 1. And then I can take that, I can push that 4 into the denominator. So now it's really x squared minus 1 all over 4 times x minus 1. Or if I'm dealing with this, if I plug 1 in here, I get 0, so that's bad. So let's play around with that for a little bit. That cancels, leaving me with the limit as x approaches 1 of x plus 1 over 4. Well, now if I plug 1 in here, I get 2/4 or I get a half. Okay, so 1/2 is the slope along the curve when x equals 1. All right, so my equation of the tangent line. I have a slope of 1/2. I have a point of 1 comma 1/4. So if I write that in point slope form, I got y minus 1/4 is equal to 1/2 times x minus 1. All right, that's the derivative. That's the equation of the tangent line. All right, this is a lot. Today's lesson is a lot of information. Mrs. Cook and I will definitely be available to answer questions. Tomorrow's lessons is a very much shorter version of this that'll take probably about 5-10 minutes, and that is it. But so be looking for that lesson tomorrow, and then we will be around to answer questions in the next couple days. All right, see you guys later. Bye-bye.